Hi everyone. Hello. Hi there. Hi. Hey. You know we can't start until you start like feedback, right? Hi. Hello. How are you all doing? If you have a laptop out, hi. Hey Will. Hi. Hello. All right. So today we're going to continue from yesterday's discussion on objects, and we'll be talking about, in particular, two different ideas about how objects interact with each other and relate with each other. So we have two different ways of defining these interactions. One way is called inheritance, and another way is called interfaces. So this will be the topic for today. Before we get too far, announcements. So I posted this last night, but we're announcing a new opportunity for a redemption. In discussion today and tomorrow, Redemption Quiz 1, which will be on the back of your discussion as usual, is optional. You don't need to do it. But if you want extra practice, you can complete it at home and turn it in at lecture tomorrow or the day after. In Lab 9 on Wednesday and Thursday, as well as Lab next week, complete a midterm checkoff and you'll get 3 points back on your midterm. So the midterm checkoff is going to replace our regular lab checkoff. And the way it works is basically, first the TA will give you like a quick explanation of a problem from the exam. And then you will go over with an academic intern and just kind of go over your thought process and just answer a couple questions from the mini lecture. Yeah, Ron, question. Great question. So everyone can take advantage of this policy. So no matter what score you got, you can receive up to 6 points, up to the maximum of 70 points for the midterm. So I think this will benefit basically everyone. Mm-hmm.
So should I download the PDF file of the redemption quiz 1 and send it to you on the next day?
Oh, Aljin, right? Yeah, Aljin asked should he download the PDF file and then like send it to me? You don't need to. If you go to discussion today, it should be the last page. So you can just take it from the discussion packet, rip it off, complete it at home, and then turn it in if you want some feedback, basically. So solutions will also be released online later, so I don't expect there will be that many people turning it in, but it's an option if you want feedback on your particular work. All right, so the midterm checkoff, the idea is that it shouldn't be too stressful, as long as you can answer and work through a couple questions like you have been doing with lab checkoff. And in discussion on Thursday and Friday, complete redemption quiz number 2. And this time it's worth 3 midterm points. But it is full credit for good effort. Just like any other quiz you've seen before, as long as you finish it and put some time and thought into that quiz, you'll receive full credit. And in total, between the two parts, you'll get 6 points, up to the maximum of 70 midterm points. Any questions about the redemption policy? All right, so I hope this will make you happy. In addition, Stan is going to be holding some midterm review session walkthrough type of thing today from 1 p.m. to 7 p.m. I don't know why he's going for 6 hours straight. I don't know what he's going to do. But you can basically drop in between discussion today, like after your discussion or before your discussion, and just kind of go over like what you can do next time to improve or what Stan thinks and how Stan thinks. In addition, we've just released post-midterm advising sessions on Piazza. So you can go on Piazza and sign up to meet with a TA or a tutor and just talk about how you feel. So it's pretty open-ended. You can even talk about like, oh, if I did poorly on this question, what should I study? I think that's a great question to ask to your TA. All right, so that's announcements. So as I mentioned yesterday, today we're also going to be talking about objects. And the goals for this week are to learn the paradigm of object-oriented programming and to study the applications of and the problems that can be solved using OOP. So today in particular, we're focusing on inheritance and interfaces, 2 ways that objects can interrelate with each other. So just as a review from last lecture, just a couple of terminology that we're going to be using in this lecture today. All objects have attributes, and attributes are kind of like names that you define in a class or that are part of an object. And classes themselves are objects too. That's why when I first showed you that first diagram, I drew a class in a box, like the class of clowns, it was in a box, right? And that box itself is also an object. It's kind of mind-bending. Instance attributes are attributes of an instance, and class attributes are attributes of a class. And so when we talk about these two spheres, so far in the course we've been talking about functions and how you can use functions to do a lot of cool things, like even define abstract data. Now we're introducing this new idea of class attributes and classes in general, and the intersection between these two spheres is what we call bound methods, where you have functions that are themselves class attributes. And functions are objects. And bound methods refer to the objects, are objects as well. And they are functions that provide self automatically. And we have dot expressions which evaluate to bound methods for class attributes that are functions. And I showed you that example from the demo, where if you just type some stuff in, like if you ask for the type of clown.dance, that is a function. The type of a specific clown's dance is a bound method. Question about terminology? Do you want me to clarify anything before we move on? Because this is very important. We'll be using these terms throughout this lecture. All right, so inheritance. Inheritance is a technique for relating classes together. And in particular, the way it relates classes together is that we sometimes define a specialized class that inherits from a more general class. So if you remember from last lecture, you might think of human and clown. There's some kind of relationship between them. All clowns are humans, right? So we might say clown extends human. And the syntax that we use to make that statement is like this. So we saw yesterday that you can introduce class, give it a name, put colons at the end, and then you can then define what that class has. So what's different today is that we now introduce this idea of a base class. Base class. So a base class is what the class inherits from. And so the new class shares, but not copies, the attributes from the base class. So this is a behavior you have to keep in mind about Python, is that when we create a new class, like for example, let's say I'm making a clown class that's based off of the human class, right? So I might say class clown in parentheses human, because the class of clowns is based off of the human class. And so if I introduce a new attribute, there's like no problem, but any existing attributes from the human class are shared, not copied over. And when I introduce new attributes, or if I want to replace an existing attribute from human, I do something that's called overriding. And implementing the new class is now as simple as specifying how it's different from the base class. So I'll show you an example of all these in the next slide. So inherited attributes. The base class attributes are not copied into subclasses. They're not copied. And the way we now look up attributes in a class is that we now have like another step in the rule. So if the name is something that we can find directly in the clown class, for example, then I can just find it there and I'm happy. But if I can't find it there, then I can look in my base class. So it should be kind of intuitive. It's similar to what we've done with frames before, right? If I can't find it here, look in my parent. But in this case, we're talking about classes. So we say if I can't find it in my current class, I look in my base class, which makes sense, right? And so as an example, we saw in last lecture that we created an account class. So what I'm saying here is, let's make a new class that's called checking account. And what checking account does is that it is based off of the account class, but it has a new feature. First of all, its interest rates are worse than the account class, which is already pretty bad. And second of all, it has an additional fee, so you get double dinged. Wow. I don't know, I'm really angry at this. But in order to implement that fee part, right, I need to somehow change the behavior of the withdraw method. When I withdraw money from this checking account, I now want it to subtract an additional fee and deduct that money from my account whenever I withdraw. So the way we can do that is if you look at the code over here, I define the withdraw method as taking in self and amount. And what it does with the total is that it first total equals amount plus self.fee. Yeah, so it first computes the total that you actually want to remove from the account by taking the amount plus the fee. And then it actually tries to withdraw using the account's withdraw method. And so as an example, if I create a checking account for Kevin, if I ask for the interest, what should this be? Well, I defined it right there as a class attribute, so it should be 0.01. Now, if I try to deposit money, this is an interesting question. What do I do when I deposit money? Because if I look at my current class, I don't have a deposit method, right? So if I don't have a deposit method, I should look up in my base class. So I'll find it in my base class, the account class, and just deposit like a normal account would. So I just add 20 to my balance. Then when I try to withdraw, this is where the special behavior for the withdraw method comes in, where I first compute the total I want to withdraw, 6, and then I withdraw that total of $6. And now I'll be left with 14. So just to kind of go over like where all these things are found, when I created the checking account CH, when I try to look up ch.interest, I follow the rule for looking up attributes of instances. And if I can't find it in the instance for CH, I look in my class. So I look in the checking account class, which has interest 0.01. So that's where the 0.01 comes from. Because I couldn't find it in my instance, so I look in my class. Then for ch.deposit, I first look in my instance, then look in my class, the checking account, then looking in the account class. So I find it in the account class. And then for ch.withdraw, I do the same process, except this time I defined it in the checking account class. So if we go through a quick demo of this. All right. So I can make a checking account for Kevin, just like we saw before. Stuff like asking for the interest still works. So my question is, when I start doing stuff like maybe I want to ask what the account's interest is. Remember from last lecture, the account's interest was defined as 0.02. Now, if I make a new account, Kevin's account, KA, as account for Kevin, this is something we covered from last lecture as well, but I can have two accounts coexisting. I can have multiple checking accounts, multiple accounts, right? Now, if I ask for KA.interest, where do we look it up? Account, yeah. So I look it up in the account class. So that's why I get 0.02. If I ask for checking account dot interest, this is just directly looks up in the checking account class and finds the interest there. So it should be 0.01, right? Now, if I create a checking account for Kevin as well, which I already did right here, if I ask for my checking account's interest, where should I look it up? Shout it out. Checking account, right? So it should be 0.01 because I found it in checking account. So here's where it starts getting complicated. Checking account dot interest equals, let's say we got an interest bump to 0.015. Got to be happy about that. So now if I ask for my checking account's interest, what should it be now? 0.015. Because my checking account's interest looks it up in the checking account class. Now, if I ask for my account's interest, it hasn't changed because we look it up in the account class. So remember that account and checking account have their own interest rates, right? So then if I change account.interest to 0.025, I should expect that my KA account, its interest should also change because we look it up in the account class. And my checking account's interest, what should it be? Hasn't changed from what it was before because we have these two separate interest rates. All right. Does anyone want me to try something else, or is there anything you want me to show up here? Questions about these two separate interest rates? What happens if I maybe do checking account.interest? Let's say I get a big bump, 0.05. I'm making big money. What should the state of my checking account's interest be? Yeah, I just assigned it, so it should be 0.05. But I also have the general checking account's interest, which shouldn't change. So make sure you feel comfortable with all of this behavior, keeping track of all these different interest rates.
So it's essentially what's going on is it's creating like a new local instance of that like attribute, and then it no longer has to look up to the class to get that like name.
Right, great question. What's your name again?
Tristan?
Tristan. So Tristan asked, is this creating its own local attribute? And yeah, it's creating an instance attribute because I'm saying CH evaluates to the instance for the checking account that I own. And interest is going to be a name that I assign to be 0.05. So I make a new interest attribute for my checking account. Great point. All right, so that's that. And now let's talk a little bit about object-oriented design. So what you can do with inheritance. So designing for inheritance, there are a couple key points. The first general guideline I want you to remember is don't repeat yourself. This is a common saying from the Professor Paul Hilfinger. Use existing implementations. And what that means is that I really want you to focus on whenever you feel like you're copying code. I think that's kind of like the general instance. Whenever you feel like you're copying code, try to do what we did before, right? Where I said, here, I can rely on a count.withdraw. I don't need to rewrite that code again. Attributes that have been overridden are still accessible via class objects. So I can still find my account class's interest rate, for example, just by saying account.interest. So if I ever want to access that, I can just jump straight to the class and say account.interest, even from checking account. And looking up attributes on instances whenever possible. So I'll show you an example of this. Let's say we have this. So this is the checking account code that we saw from the last slide. We have an interest rate 0.01 and a fee of 1. But notice here, the self.fee, why did we not say checking account.fee? Think about it for a moment. And then converse with the person next to you. Why do we say self.fee instead of checking account.fee? Go. All right, this one should be pretty quick. Let's wrap up. Hello. All right, so the reason why we use self.fee instead of checking account.fee, the reason why we use self.fee instead of checking account.fee is provide this idea of specialization. So remember what I did from the demo where I set my checking account's interest to be 0.05? Like what if I want to set my fee to be $2 or $10? Maybe I'm just like, maybe the bank thinks that they can get away with it just for me. So then saying self.fee will make it look up in the checking account object itself in case I have like a special fee or if I have a special interest rate, right? And if it can't find it there, it'll still look in the class, right? So it still works out. I can still find the fee from the checking account class based on the lookup rules. So this provides both that ability to find a specialized fee for myself if the bank thinks that they can get away with it, or it can also look up for the general checking accounts fee. And here's the DRY. Don't repeat yourself. Reuse code from base class. Questions about any of these three principles? They're a little abstract, but as you work with the Ants project, you'll have like more experience with it. All right, cool. And here's a fun example, an energizing example. Say hi to Pikachu. Woo. I think it's been like a little bit too long since. Okay. Wow. Yeah. Okay. Well, that's Pikachu. And Pikachu is a Pokemon. So the docstream says a Pokemon. And Pokemon have the following attributes. They have a name. They have a trainer, which is the person that is kind of responsible for that Pokemon and uses them. A level, which is it represents how much experience the Pokemon has, an amount of HP or life, and an attack that's called tackle. So Pokemon have all of these attributes. They are properties of the Pokemon. So we might define them either as class attributes or instance attributes. And Pokemon have behaviors as well. Pokemon can say their name, they can speak, and they can attack other Pokemon. So this is like the interesting part where you have behaviors between objects. Like what happens when I have this Pokemon attack this Pokemon? Something to change about their attributes. In addition, let's introduce a specialized type of Pokemon. Let's call it electric type. An electric type extends from the base class of all Pokemon. And electric type Pokemon have a lot of similarities. They also have a name, they also have a trainer, they also have a level, and they also have HP. But their attack is a little different. They have a Thunder Shock attack. And what electric type Pokemon can do is that they can also say their name, so they also have somewhat similar behavior, but their attack is a little special because it can sometimes paralyze other Pokemon. So if this is our intended behavior, if we want Pokemon, we want to define two classes that can do all of that, well, let's take a look at it. So I'm going to show you what our expected behavior should be. So we'd like to be able to do this. I'd like to be able to create Squirt as a new Pokemon that's called Squirtle, and who has a trainer that's me. And so now if I ask for Squirt.trainer, I should get myself. So we've saved like these attributes about the Pokemon into Squirt. And I can also do things like ask for Squirt to speak and says Squirtle. It speaks its name and puts an exclamation mark at the end. And I can also create other Pokemon. Like I can make Bulbasaur. And Bulbasaur's trainer is Stan. So we're going to have some fun battles here. Bulba's HP, all Pokemon have 50 HP to start off with. And now if I try to do something fun, let's start doing some attacks. Let's have Squirtle attack Bulba. Well, what should occur is we speak. Squirtle. Squirtle used Tackle on Bulbasaur because Tackle is the default attack for all Pokemon. So now if I see what happens to Bulbasaur, what's its HP look like? It's a little lower. So it's super effective. So this is the intended behavior we'd like to have, right? And so now let's also take a look at the code. So, Control AC. Let's look at 16.py. So there's my checking account. Let's go down, Here's the Pokemon class. Here are the lines I just tried. So created Squirtle, created Bulba, and I made Squirtle attack Bulbasaur. And the definition for the Pokemon class looks something like this. I've given it a basic attack that all Pokemon share. They all have a tackle. I've given them the same damage because I haven't done anything special with the damage yet. And I've made these particular instance attributes. So far, both of these are class attributes. They're something that's shared by all Pokemon. But each Pokemon has a different name. They might have a different trainer. Their level is going to be independent because the amount of experience or the amount of time you spend with that Pokemon will affect their level. Their HP all starts at 50, but as you saw earlier, when I attacked Bulbasaur's HP dropped, but Squirtle's HP still stayed at 50 because it was an attack. In addition, we have the paralyzed attribute for when we introduce electric type Pokemon. We didn't know whether a Pokemon is paralyzed. So speaking, like we saw earlier, it just prints the name plus an exclamation mark at the end. And the attack works like this. If the Pokemon is not paralyzed, what it'll do is it'll first speak its name. So if you remember, it said Squirtle. So it's speak. And then it printed self.name, so Squirtle, used tackle on Bulbasaur, exclamation mark, because it's exciting. And then other.hp, so other is Bulbasaur. Bulbasaur's HP is equal to the max of 0, and the amount of damage that I caused to Bulbasaur. So that means I just can't go below 0. Like you can't have negative HP. Like you're gone after you get to 0. And if Bulbasaur's HP reached 0, I would say Bulbasaur fainted. Oh no. And so this is the basic implementation for the Pokemon class. We can see also the way we define the electric type Pokemon is that I'm going to introduce a new attack, Thundershock. Right? So this basic attack, notice it has like the same name. It has the same name as the class attribute for Pokemon, right? So electric type Pokemon have the same class attribute basic attack, but we know the behavior for checking account kind of gives us some idea of how this works, right? Because now it overrides the regular Pokemon's attack. And we additionally define a new class attribute for probability. So this is the probability of how likely you are to paralyze a Pokemon. So if we look at the attack method, notice that we didn't have to repeat ourselves with the speak method. Because if I can't find the speak here, what the electric type Pokemon will do is it'll look up in the regular Pokemon and just use their speak. So what the special attack does here is that I use the regular Pokemon's attack, which will cause some damage. But in addition, if it's the case that I roll some random number between 0 and 1, if that random number is less than 0.1, and the type of the other Pokemon is not electric type, then I'll paralyze that Pokemon. I'll set maybe Bulbasaur's paralyzed attribute to be true, which means that they can't attack anymore. And then we'll additionally print out that Bulbasaur is now paralyzed. So you'll be doing something similar with Ant's project. So this will be pretty fun if you like this example. So if we switch back to the slides, let's take another look at this. So we saw the code for electric type, and it had the following lines: basic attack, probability, redefined attack, having the following lines. And if we look at the properties of this code, it doesn't repeat itself. It doesn't redefine speak when it doesn't need to. And it calls Pokemon.attack. We don't need to copy over the code for Pokemon.attack. We can just call Pokemon.attack. And it reuses overridden attributes by accessing them through the base class. So for example, it uses Pokemon.attack again because this is an overridden attribute. The attack method, right, is defined in electric type. But I can access them through the base class by saying Pokemon, the base class, .attack. And I can look up attributes on instances where possible. So here, I look up self.probability instead of electric type.probability. Because I want to know, like maybe this electric type Pokemon I want to make has a certain probability that's different from another electric type Pokemon. Are there any questions about this Pokemon example? I kind of want to try it out, so yeah, question. Mm-hmm.
Earlier in the base case of Pokemon, you defined on self-damage. And I didn't really see we define what that was.
Good question. So here we did self.damage to figure out how much damage should be caused to the other Pokemon, right? And what was your name again?
Mark.
Yeah, so Mark asked, where is damage defined? So maybe I'll try to look in my instance attributes, which are normally defined here in the init method. Can't find it, but then I can look it in my class. Yeah, so it's based off of the class attribute that all Pokemon share 40 damage. Mark, go ahead.
And how, I know this is others on HP, what's that exactly is, like, is that like some kind of thing like self or?
Yeah, great question. So Mark asked, how do I interpret what other means? Let's first look at the behavior. So I made this call the squirt.attack Bulba, right? So squirt is going to be myself because I know that methods pass in self automatically. So squirt is self, and that means Bulba is other. So that gives us some context for when I defined attack. This other means Bulbasaur. So it's like saying I'm going to set Bulbasaur's HP to be reduced to whatever value is here. Does that address your question? Awesome. And now I want to try out some fun stuff. Let's see. So I can try Pika equals electric type Pikachu. I think this is what we've all been waiting for. And then I guess I'll make it stand this time. He gets me lucky. So Pikachu has Stan as his trainer. And if I ask for Pikachu's basic attack, which one should it look up? Should use Thundershock, exactly. And it has all the properties of regular Pokemon. It can speak. And if we try to attack maybe my Pokemon Squirtle, Pikachu used Thundershock on Squirtle. So that also caused some damage. So hopefully we should see that Squirtle's damage, Squirtle's HP, has been reduced by the regular damage amount, because all Pokemon currently share 40 damage. Pikachu shouldn't have been damaged, so it's still 50 HP. And so now if I try maybe something like Pikachu to attack Bulba, Pikachu used Thundershock on Bulbasaur, and Bulbasaur fainted because they only had 10 HP earlier. And now Bulbasaur is also paralyzed, so that's like a double whammy. Yeah, so you can try this example at home too. All right. Moving on, multiple inheritance. So in Python, a class can inherit from multiple base classes. And there exists many, but not, this exists in many, but not all object-oriented programming languages. So if you've done Java before, it doesn't have this feature. So I'll show you an example of what that means. But in general, this is kind of a tricky and dangerous subject. So you have to be careful where you use this and kind of consider like what cases are appropriate. So I'm going to show you a new type of Pokemon that's called Flying type. And Flying type Pokemon have a basic attack that's Peck. They cause 35 damage. And when I try to fly, I can say that my trainer flew to some location. So it's a nice way to travel. I'm going to introduce a new Pokemon that takes advantage of multiple inheritance. So we can call it Zapdos. And Zapdos looks like that. It's pretty scary. And Zapdos is a legendary bird Pokemon. And Zapdos has an attack, Thunder, that does a lot of damage. Zapdos can also paralyze when attacking. So this is similar to all the electric type stuff we've seen so far. And Zapdos can also fly. And Zapdos can't say its own name. So we can see that there are some properties shared between both electric type properties, right? It has this paralysis effect. And it also has this flying type effect, right? But it also has some of its own properties as well, that it can't say its own name. So if I define the class Zapdos as extending two base classes, this is the multiple inheritance part. It is both an electric type Pokemon as well as a flying type Pokemon. Its basic attack is just called Thunder. So we override the basic attack. Its damage is really high. It does 120 damage. And when it speaks, it just does yeah, it can't speak its own name. So this is an example of that. And I just wanted to show you how you might think of this as on a diagrammatically. So we know that we've defined a class Zapdos. It extends these two base classes, electric type and flying type. But electric type and flying type also themselves come from the base class of all Pokemon. So I'm going to show you an example of what its behavior looks like. So if let's see. Let's go ahead and make some new Pokemon. So let's try it again. Python 3-i 16.py. Oops. So now if I make a flying type Pokemon, flying type, that's called Pidgey, and whose trainer is Kevin. I've made a Pokemon like that. Pidgey's basic attack should be based off of the basic attack for all flying types, which is Peck. Pidgey can also fly because it's a flying type. So I can say maybe I want to fly to Pallet Town. And so Kevin flew to Pallet Town. Woohoo. In addition, let's also make a Zapdos. So I can make a Zapdos, which we can call Big Bird, and whose trainer is Kevin. And so when Zapdos tries to speak, it goes, "ee." And when Zapdos tries to fly, because it's a flying type, right? Because we know Zapdos is a flying type, it should be able to fly. So I can try to fly to Lavender Town. Lavender Town, and I should say Kevin flew to Lavender Town. And when Zapdos tries to attack Pidgey, it first speaks its name, then it says, Big Bird used thunder on Pidgey, and then I happen to cause Pidgey to faint, and it's also paralyzed. So this super unlucky duo again. So that's an example of where multiple inheritance, where we can look up either in attack, which is from Pokemon, or which is from electric type, right? And also from speak, which is from the Zapdos class. And we also have like all the properties of everything we've inherited so far. So it knows about its own basic attack, it knows about its overridden damage, and so forth. Question, yeah?
If you didn't override the basic attack, would it give you an error?
If I didn't override the basic attack, would it give me an error? Let's actually try that out. Because there's, so what's your name?
Daniel?
So Daniel asked, what happens if I don't override this? I think he's bringing up an interesting problem. So if I take out this, oh, my bad. Let's scroll down a little bit. So let's look at Zapdos, right? Zapdos has a basic attack, Thunder. So what happens when we take it out? So I want to point out what the problem is first. So if I've taken out the basic attack, remember that Zapdos extends from two different classes, electric type and flying type. But electric type and flying type have their own basic attacks, right? So which one do you look up? Because let's look at that again. So we know that Zapdos extends from both. And flying type has a basic attack, Peck. And electric type also has its own basic attack, Thundershock. So which one do you choose? Which one do you look up? When we normally have this problem, Python has a way of solving this that's called linearization. You can come talk to me in office hours if you're interested. But let's just see what happens. I think it's probably the best way to demonstrate this. So if we try to import it, and now if I make a Zapdos, I think I saved it. Yeah. Yeah, I saved it. So I made the change where I removed Zapdos' basic attack. So now if I make a new Zapdos, let's call it Big Bird again. This time maybe Stan can have Big Bird. And let's also create a Pidgey. It should be flying type. And Pidgey's name is just Pidgey, and its trainer is Kevin. And so now if I try to do Zapdos.attack Pidgey, Big Bird used Thundershock on Pidgey. So it chose the first class. And maybe your intuition for this problem can be, if there's a case of maybe, let's just bring it down again. If there's a case of ambiguity, right? This is the problem here, ambiguity. I don't know whether to look up in electric type or flying type. The order of these classes can matter. So maybe if we swapped around the order, we'd get a different result. Any other questions about multiple inheritance? Yeah, Tristan.
Yeah.
Yes.
You have if you wanted to go up to the electric type class, even though you did have a basic attack, could you like a non-local type thing to get the basic attack from the base class?
Right. So Tristan's question was, if I wanted to specifically specify electric types at basic attack, is there like a non-local or something similar to that we could do? And I think we can usually just rely on, I showed you something similar before, but I could just say, if I wanted to use to reference the basic attack, I could use, maybe I can say electric type dot basic attack. That's one way. If you want to follow Python's lookup procedure, because we know that when you have ambiguity, you don't really know which parent to look up to, which base class to look up to, right? There's an additional Python feature that I won't be teaching you, but you can look it up. It's called super, S-U-P-E-R. You don't need to know it, because we won't be talking too much about multiple inheritance, but it's a useful feature in case you're interested in that kind of detail. Okay, any other questions about multiple inheritance? Yeah, Martin.
So for this case, the electric type and flying type shared its own base case.
Sorry, can you repeat that?
Electric type and flying type were like those Pokemon.
Uh-huh.
What if the two base case shared a different base case? Like will we have to give a new way of initializing that thing?
So Martin's question was, what happens if I have electric type and flying type have different base classes? They would still try to look it up using the standard lookup procedure that we saw in where you try myself and then try my class and then try the base classes as you go up, right? So there's like a special linearization procedure that I mentioned earlier, but come talk to me later if you're interested in it. Okay. So just a note on design, because this example that I showed you isn't exactly accurate. Instead, what we should have designed is a class for every species of Pokemon. Because you notice how we had like these kind of weird design choices where I said there was a class for Pokemon, a class for electric type, a class for flying type, but then suddenly a class for just Zapdos on its own. And that just seems kind of weird to me. So we should instead create a class for every species of Pokemon. Like I might create a class for Pikachu that extends electric type as its base class. That could be an option. So we should not create any instances of Pokemon electric type or flying type, because these are kind of like the templates for our real classes like Pikachu or Zapdos that actually are Pokemon, that actually are flying types, that actually are electric types. We should create classes for different types of attacks as well. So this is like even going beyond the idea of just individual Pokemon, but the attacks themselves should not just be strings, because strings don't carry any information besides the name, right? Like maybe you want attacks that do different damage, or maybe you want attacks that cause different effects other than just paralysis. So if you're ever kind of in a position where you feel like I need more information, create another class for it. Don't try to stick it into a string. The relationship between classes that reference each other, like Pokemon and Tackle, is called composition. And what that means is, remember that we had an attack called Tackle. And we kind of just put that Tackle attack as a class attribute. If I make Tackle a class of its own, and I put that class inside of the Pokemon class, then it becomes what we call a technique called composition, where I can have a class of Pokemon that contain within it certain different attacks, and each of those attacks are their own classes. So that's called composition. And good design is a bigger topic in future classes, and in particular CS61B. So we won't be talking too much about this, but you can see an example of kind of like some of the ideas here in ants. And finally, we'll talk about complicated inheritance. So these are some of the complications. I kind of already showed you something similar where we saw that the multiple inheritance example already got pretty complicated, where I don't know which one to look up necessarily. So let's take that to like this logical extreme, biological inheritance. Let's say we have 4 people. We call them grandma, gramps, grandpop, and grandmom. And of course, they're related to their children, what we call mom and dad. And there's you, who inherits from mom and dad. So you have like this genetic tree of sorts, and it looks pretty normal, but let's introduce some more people. So you have an aunt as well, right? And your aunt inherits from your grandma and grandpa, gramps. But it turns out that your aunt was actually inherited from some other guy. Yeah, so this is getting spicy. And that aunt had a half-cousin, right? And the half-cousin inherited from the aunt and some other guy. So the story is just getting more and more intriguing. But it turns out your half-aunt actually inherits from your grandpa. Oh, God. What? That some guy was actually your grandpa. And it doesn't stop there, because now we call her my double half-aunt, because somehow you're related to her twice. And that makes your half-cousin your double half-cousin. And it turns out you have a double half-uncle as well, who's related to your grandmom and your gramps. No way. What happens next? Well, it turns out your double half-cousin inherits from your double half-aunt and your double half-uncle, which maybe makes them a quadruple half-cousin. So the moral of the story is inheritance is complicated, so don't overuse it. And oftentimes we come to this scenario where we have to think about how I'm designing my classes. Because if I don't think ahead, it'll be easy to get into these kind of situations where you have to change all your code constantly to adapt for new scenarios. All right, break.
Yeah. Sometimes like which attack will flop has no like self dot, but other expressions like names or trainers has self dot expressions, right? Like, what is the difference?
Oh, the difference between
The-
self.prop and
Yeah. And I mean the usage of init underscore init.
uh-huh.
Why do you use that?
Oh, we'll talk about that later in lecture. Yeah. Why we use underscore init? Yes. Oh, what's your name, by the way? Haruki. Yeah.
So you talked about multiple inheritance and the conflict. So you said there's like some linear process. So does it just like look up the first class, and once it finds, it goes through like the class. It's not the instance itself. It goes through like the base class. So it looks at the once it finds the first instance from the class, it just uses that one. It doesn't look at it. It stops looking for other.
Right. So it goes through this linearization to make it linear, to make your history linear.
Yeah.
So it just goes through the process of looking up in that linear order.
And once it finds it, it stops.
Right. Yeah. So it finds it in the closest base class, basically. Yeah. You can look up the particular thing. It's called C3MRO. C3MRO. That's what it's called.
Why is it here like if I call like account or balance?
So is balance a class or instance attribute?
So like it is somewhat like belongs to itself.
Yeah.
So it is like okay, I got it.
Yeah, because it doesn't make sense. Account refers to all accounts, but then the question is, which account do you mean, right? Because each account has its own balance.
Yes.
That's the problem.
So I need to call like a history.
Yeah, exactly. Yeah.
And also like it's this code is
Yeah, it overrides.
So
Say it overrides.
it means that somehow the father class of this class, so
Right.
and I like change the attribute by myself.
Change the attribute. Are you asking, does this change the parent, the base class
Yeah,
attributes?
Is it like this?
Great question. So the way it overrides is, if you imagine I have electric type, right?
Yeah.
So I draw a little box for electric type.
Yeah,
It has its basic attack, that is thunderstorm, right?
yeah.
But now when I draw a new box for Zapdos, it has its basic attack that's called thunder.
So I took this box and then changed a little bit of it.
I would say you actually just make a new box, and it doesn't know anything about the parent. It doesn't know anything about the electric type. I just define in this new completely blank box, I define thunder attack.
So the basic attack will no longer be like the parent. Yeah.
I think the best way to think about this is like you follow the lookup rule. So I have a Zapdos, and if I ask for basic attack, where do we look?
In the current class.
In Zapdos, because you find it there.
Yeah.
But if we didn't define basic attack in Zapdos, where would we look?
Like the parent.
I'm looking electric type. Yeah. Oh, and then I find that electric type. But defining basic attack in Zapdos doesn't change electric type. It doesn't change it.
Thank you.
Yeah. Hey, Isaac. Oh, what's your name, by the way?
Terrence.
Terrace.
Yeah.
Terrace. Okay.
So
Yeah. Hey,
if I
Audrey.
turn hello,
Yeah.
if I turn it at the next lecture, can I get extra points?
Oh no, it's just if you want feedback.
Also, how
Yeah.
can I
Sorry.
how can I get the points? So should I
Which
should I submit
one?
should I submit the written case on the discussion section?
This is for no points. It's not worth anything.
Ah.
Yeah. Yeah. So it's just if you want to do it on your own, you can do it. Yeah. For practice.
So how can I will ask you next time.
Okay. Yeah. We can talk about it at the end. Hey, Isaac. What's up?
So for the Pokemon example,
Yeah.
we're defining a class for every single Pokemon, every single type, every single attack. How do we organize all these classes? Like with the text adventure game, I was already having trouble like moving down the place implementations and like figuring out where I was and what materials were on. How do you organize tons of classes and make classes for every single game?
In terms of like where you write the code, or
Yeah.
that's actually an interesting problem that we spend a lot of time talking about things actually when we practice a lot. But basically, I think it's up to you. It depends on like how large you think your file should be. We usually split it up into multiple files. But Python's pretty flexible. You can put like however many definitions you want in any one file.
And then just do, like from file import.
Yeah. So you can put in like maybe multiple classes if you feel like they're small enough or interrelated. So that's also a design problem, right? Like how many classes should I put in this file and how should I divide my files up? Yeah. This is something you think about on your own. Maybe you talk to people around you who are working on your project. It's like the whiteboarding phase, basically. Yeah. Hey, what's up?
Hey, so
Yeah.
so my composition got a 1, and
Right.
I was looking at Lucy's the different the way to look at it that looks good. Here. This one.
Right.
Okay, so
Oh, actually, if it's Matthew, you can just talk to him. He's right over there.
oh wait,
Matthew, the guy sitting in the ground
wait,
in the white shirt. Yeah.
the white shirt.
Yeah. He can just answer your question straight away. He's the one who gave you the comments. Hey, Joanne. What's up? Yeah.
Like, if I wanted
Oh, cool.
dimension, if I wanted to
Yeah.
do it here versus like, what's the difference?
Well, over here, is that a class attribute or an instance attribute?
Oh, that's a class.
And then what's the? Oh yeah, go ahead.
So like, but then, like every single instance I make, if I put self-dimension equals to here, like every instance I make will have this, like the dimension would be 2.
Right.
So there wouldn't be any shapes. So like if I like did 3, there wouldn't be any shapes with the dimension 3.
In effect, yes.
Yeah.
But if you think about the diagram, it's a little different, right?
Okay. Okay.
That's kind of the main
Okay.
difference. Yeah. Yeah.
Just a
Yeah.
question. So, what do you mean like the redemption quiz is graded based on good effort?
Oh, it's the same as regular quizzes. So you get credit as long as you fill it out.
No, it's not based on accuracy, but
Like I'll give you a grade based on accuracy, just so you
Okay.
know. But you'll get credit just by filling it out.
okay, I see.
Yeah. All right. All right, back from break. Interfaces. Interfaces are really cool. So let me start with a quote. My late friend Alan Fournier once told me that he considered the lowest form of academic work to be taxonomy. And you know what? Type hierarchies are just taxonomy. You need to decide what piece goes in what box, every type's parent, whether A inherits from B or B from A. I believe that's a preposterous way to think about programming. What matters isn't the ancestor relationships between things, but what they can do for you. And that was said by Rob Pike, who is the co-creator of the Go programming language, which is really popular in systems, and Google uses it a lot. So, I've shown you inheritance. Now I'll teach you a new technique called interfaces. I forgot to animate this. Whoops. Programs often require communication between multiple components. This is kind of the problem we were mentioning earlier. I have Squirtle attack Bulbasaur. And I also want Bulbasaur to be able to attack Squirtle. They have communication. They have some way of interacting with each other. Communication between the program and the user, between two different parts, and between two objects in the same program. So there are different types of communication that we can think of. And this can get very complicated since these components often have different behaviors and specifications. Like we saw, for example, that electric type Pokemon do different things from regular Pokemon when they attack. And inheritance is often the wrong tool for enabling communication between different parts of a program. So if our only goal is to try to have different Pokemon be able to attack each other, then inheritance might not be the right tool. Instead, interfaces are a specification of the rules for communication. To use an object, we don't need to know how it is implemented if we know the interface for that object. So think back to data abstraction. When we had, like, for example, selectors and constructors, or when you're thinking about functions in general, when I think about a recursive program, I think about its behavior. I think about what it takes in, what it gives out. So this is kind of a similar idea, where we don't need to know how it actually works, we just need to know what it does. The additional complexity of objects is that when I talk about objects, it can also change the attributes of that object. It can change the HP of a Pokemon. So that's the thing you have to be concerned about when you're thinking about behavior. It's not only what does it take in, what does it take out, but what is its effect on the environment. And Python has a common interface that's called protocols. So I'll show you a couple of those protocols. We've seen before that I can create Pokemon. Created S for Squirtle, B for Bulbasaur, P for Pika. And they all have this common function that's called init. And we usually find it in the Pokemon class, right? We defined init in the Pokemon class, and somehow Python knows when I say Pokemon and put parentheses after the class name, somehow Python knows to look up the init method and call that method. And in the same way, we can use the length function on all different types of objects. I can call the length of a list, the length of a dictionary, and the length of a string. And somehow Python knows that all of these have some underlying function called underscore underscore len underscore underscore. And we call this idea of having these underlying functions, like init and len, we call this idea interfaces. Because interfaces basically just say that if I want this behavior, then I just need to define this function that works in a certain way. And we call these methods in particular magic methods. So whenever you see these two underscores in the front and the back, it means a magic method. And these are special methods surrounded by double underscores that add magic to your classes. So basically, I mean, they have a pretty nice name too, magic methods. We'll look at two examples of these interfaces. The arithmetic interface, so like how you can add together two strings, add together numbers, add together lists. It's the same idea as that, as well as the mutable container protocol. So for example, with dictionaries, I can add keys to a dictionary, right? I can say dictionary bracket Kevin equals list of S. And that's part of this mutable container protocol. So let me show you a quick demo. I'm going to show you the behavior first, kind of like before, and then I'll show you the code afterwards. Okay, so we'd like to be able to define a class of rationals. So I think Stan showed this in a couple lectures ago on data abstraction, where you could define rational numbers that have better precision than Python numbers. Like we had that 0.999999 problem, right? And the way we solved that was we had a rational number that could represent that without working out the division. So I'd like to be able to do the same thing. I'd like to be able to say x, let's maybe just do x is a rational number, 3 and 5. So those are the two parts of the rational number, 3 divided by 5, 3 over 5. Let's have the rational number y represent the rational that is 1 over 3. So now if I ask for x dot value, I can compute what that rational number is when represented by Python, which gives me 0.6, 3 over 5. Now the interesting thing about magic methods is that I can now do this. Rational is a class that I defined. X plus y works like magic. So we can do this. We can essentially take advantage of Python's really nice syntax for adding two numbers without having to go through like something clunky like rational dot, I don't know, maybe like the annoying version would have to be would be doing this. X dot add y. That's the annoying version. What we get is we can do x plus y, which is really nice. But what this kind of really does is it calls an underlying function that does that. X dot underscore underscore add underscore underscore, and then you pass in the second argument. Essentially what Python does is it converts this format to this when it sees the plus sign. So if we do the same thing, we can try some other operators. Like I can say print. Print is also a built-in function. I can print x, and somehow Python can know to print the rational representation of 3 over 5. And that's also part of a method that's called __ stir, which is the string representation of that object. So if I try to call that method actually, it gives me that string 3 over 5. So Python has these underlying magic methods, like __ stir, __ add, that we can access using some nice syntax like x plus y. So long as we define these methods in our class, we can get really nice syntax that is really awesome. So if you're used to Java, this is a nice surprise. All right, so let's look at the implementation of rational. So here's the code for rational. I've showed you a similar example to that. You can also do multiplication and subtraction as well. And we have the magic method for init, which we've seen before. It's like the constructor, it makes the object. And so a rational number takes in 2 arguments, a numerator and a denominator. So 3 and 5, numerator is 3, denominator is 5. We go ahead and compute the divisor, just so we can reduce the number to its lowest terms when we try to store it. And then here's the magic part. So we can skip value, but the magic part is here. I can define a method like __ stir, which will be called by the print function. I can define functions like __ add, __, which will take in some other, one argument other. So when it does x plus y, it'll pass in x as self and y as other. And then it'll compute this and it'll return your new rational number out. And same thing with multiply, subtraction, and so forth. So you can keep on defining magic methods like that to get the behavior we want. Yeah?
I'm still not understanding how you're able to use the plus operator in this code.
Right, great question. What's your name?
Sam?
So Sam asked, why can we use the plus operator here? And that's just basically a feature of Python. It says, when I see the plus operator, I actually convert this to __ add. And that's how it knows how to add these 2 things. It's basically like a feature of Python that just says, take this and into this. Yeah, so it's just a feature of Python. Don't have to worry about it too much. But just know that it takes this and turns it into this. Yeah, it would do the same with mul. So if I do x times y, for example, it gives me 3 over 5 times 1 over 3, which is 3 over 15, simplified to 1 over 5, right? And if I try doing the same thing with x __ mul y, I also get 1 over 5. So I'm not going to show you how exactly the magic of transforming the calls works, but they have the same behavior because they call __, the magic methods. Does that clarify? Or
Yeah.
Okay, cool. Any other questions? All right, cool. I'll also show you another class. That's called the dictionary class. So if I go ahead, exit, clear, and pull up Python again. Let's say I want to create my own dictionary. I made my own class called dict. I'm going to show you the behavior. What dict does is it takes in 2 lists. So for example, I can have a list of 1, then A, then true, then 4. And what this first list is, it's a list of my keys. So I have a key for 1, a key for A, a key for true, a key for 4. I can take in a second list of values. So these will represent the values for each of those keys. So I can have anything for the values as well because they're just a Python list. So I've given it the keys and the values. And the way to interpret this is like 1 is mapped to 5. The string A is mapped to the number 2. True maps to list 1, 2, 3. And 4 maps to hello. So this is what we should see in our dictionary. So when I create this dictionary, which is my own class, I can ask for the length because I defined an __ len method, which gives me 4. And that's the same result I get from calling __ len with 0 arguments. And I can even use nice syntax like if I ask for the dictionary with key of 1, what's its value? Should give me 5, right? So that syntax works just the same, and it works because I implemented a function called getItem that takes in the argument I want. So Python is doing more of these conversions where it says take this and turn it into this. I can even do stuff like for in D. And it'll know that because it defines a contains method for. And I can do reassignment. So this is the interesting part where I can do set item as well. So I can reassign. No longer will A be the number 2. Now it'll be high. So now if I ask for D of A, that's also high. And that relies on a method called __ set item, which takes in more arguments. So I'll show that right here. All right. So we saw a couple of these lines earlier when I was just entering them in. And you notice that we defined a length function, which just returns the length of the list of keys I was given. So remember that we defined this dictionary as taking in 2 lists, one representing the list of keys and one representing the values. So we'll just store it in the same way. Essentially, we have like a list of keys, and when we get the index for that key, we'll look it up in the values. So if I know the length of my dictionary is just the length of its keys. Get item we can define as just finding the index for the key I'm looking for, and then returning from the list of values that index. Right? And same with all of these. I can define get item, set item, contains, and I can get all the behavior I want, as well as delete item. So this is just an example. You can take a moment to read it at home. But I just wanted to show you some of the power that you can do with Python. Yeah?
How is the well-known operator recognized and then binded to the method that you define?
Which operator?
Like any of them. So like when you do length out LESD, it calls that method that you define. Why does it do that?
Right. So length is a built-in Python function. And you can kind of think of length as being, like maybe I want to define something that's similar to length. Length takes in some object, right? And what length will do is it'll return object dot __ length. So you can basically think of it as that. So if I ask for the length of D, it works kind of the same way.
So you can find that in documentation? Or?
Oh, this is all built into Python. So it's like what you get from when you start out.
Right. So
right.
We need to know that before we can create those methods, correct?
Right. So how do you know what to type for __ get item or exactly? So all that's in documentation. We won't really ask you to write too much of that, but it's just an interesting point that I think is useful if you're writing real code, right? Because you'll see this a lot in real code where it's just a lot more convenient to use this nice syntax instead of having to write like complicated functions. Yeah, so all that's like stuff you look up. Like you essentially just go on like Google or some other search engine and just type in, how do I do delete item? And then it'll probably pop up. All right. So those are the mutable container interfaces. So just as a recap of all that information, we've seen that Python has many built-in containers like lists, tuples, dictionaries, etc. But we can also define custom containers like we did before. And we just have to implement the magic methods. Like our class can have any base class. It can have anything it wants as long as it has the right methods in it. So some methods that you might be interested in are, for example, the len method, the get item method, the contains method, and some of the others that I showed you earlier. And so to create a mutable container, we just have to additionally define set item and delete item. So if you want to be able to change your containers items, just define these two as well, and you can do the nice bracket equals something else. Questions about custom containers? Yeah, Will.
Dictionary is just a class.
Yeah, so I defined like my own dictionary that I showed you the code for earlier, but the dictionary Python uses is also its own class, right? Other questions? I already showed you the demo for that one. So So let's go ahead and move on to the summary. So inheritance, as we remember from earlier in the lecture, allows us to implement relationships between classes and simplify our programs. It lets us avoid repeating ourselves because we can just say, call from my base class the attack method, Pokemon.attack. Interfaces allowed for standardized interactions between different components by defining the rules for communication. So long as I have a len method that takes in self and no other arguments, then I can use the len function. And implementing these interfaces in Python can allow our custom classes to behave like built-in classes. I can do stuff like call len on an object that I define. I can do indexing. I can even do slicing and other cool things. And both of these are tools for abstraction. So let's just think about programs like our dictionary or a rational number without having to worry so much about the details of the implementation, but just say, I really just want to add these two rational numbers together. What do I type? X plus y, simple as that. So long as I define that __ add method. And that's it for today. Thank you very much. Yeah.